here and there, so it was delayed. I believe from next week, maybe it will be posted in advance. Okay. I posted the syllabus and also brief description about the CA and also first set of lecture notes. I believe you all printed out all those things. Syllabus, okay, the entire syllabus, learning outcome and other things are there at the IVD. You can go through that. In this syllabus, here I give the syllabus for my part. There are two lecturers. The other lecturer, Dr. Mekul, will be teaching the second half. Okay, and we start with what's called basics of networks, the big picture of networks. What are the building blocks? Okay, what are the challenges? What are the functionalities of different network units, etc. Okay, then we look at the network functions at the link level when you connect the computer to switch or router. Okay, what are the issues and the functions, protocols we need to do. Okay, then later in part 2, we will be looking at more like routing issues, like how your packets, data packets are routed from one end to the other end, how it goes to different networks, how it chooses the path. Okay, those things will be studied in the second part. Okay. So basically there are many textbooks or reference books. Many of my more notes, lecture notes will be from here and some here from here. Okay. And here and there I may take notes from others as well. Some slides could be from others. Okay. So what I would suggest is any one of these two books should be okay. The first two books should be fine. And if you follow closely the lecture notes, should be more than enough. The books would be a supporting reference material. That means if you don't understand certain topics, you can go and read more on the books. But I always encourage you to read books. Don't just stick on to the lecture notes. But it's a very established subject. That means any book you read, they all discuss almost the same. Only the treatment, some examples, figures will be different. Otherwise, algorithms, protocols, methods, everything will be the same. Is that fine? This is something like basic math. The basic math should be same, but different books may give different treatment, different examples. Okay? So it's up to you. Okay, some people like this book, some people like this book, doesn't matter. So I give it to you. Okay. Regarding the assessment, so there are 3 continuous assessments. The first one, we call it as network programming assignment. Basically, it involves network circuit programming, maybe C and Linux platform. So you need to write some programs, okay, to transmit packets from one end to the other end, and you'll see how packets flow and how you will also measure the performance, etc. And I'll be giving you some quick reference material and also some set of programs. So once you understand those programs, you can develop assignments on top of those programs. That means I provide a set of functions programs, use them, and add some additional functions to solve the assignment problem. You don't need to write all from the beginning from scratch. So later I will post those programs, and this will start only after the break in October. The lab sessions will start in October. Basically, there will be 2 lab sessions. One is mainly for the practice sessions with the graduate assistants and we. Okay, so you can practice those sample programs which I give. Okay, and to start with the assignment. And the second lab session will be for demo. You need to demonstrate your work. So there will be only 2 lab sessions. Is that fine? But other than that, you can do your lab work at home or in the office, maybe in the lab, anytime. You can also do if you have computers, laptop. But only thing is you need to have Linux. Is that fine? Linux is a free software. You can always download it. But you can have both Linux and Windows as well. Or you can connect to NUS network. You can work there. You will be given an account in the Linux lab, so you can go there anytime and you can use it. You can also do it in Windows, it's up to you. Okay. But the programs which I'm going to give you, they are basically in the Linux platform. Okay. There may not be much difference, but there will be some differences. Is that fine? So it will be easy for you to develop further based on my programs, okay, rather than starting from the beginning in a new platform. So if needed, you may have to come to the lab. I think you can remote login also do something from there. You can see. Is that fine? Then we have two tests, one on my part, one on part 2. Okay, the first test would be immediately after the research week. Okay. You have research week, so you make use of that time to prepare, study, revise, everything. Then you come back, you'll have the test. Most probably I may test in the evening or maybe Saturday daytime, Saturday afternoon. So it depends. Similarly, there's another test on the part 2. So that test will be conducted at the end, maybe the last week of your lecture, last week or maybe week 12. Okay. And this case is 20 marks, 15 marks, 15 marks. So in total 50 marks for CA, 50 marks for final exam. Any questions?
So you mean CA2 and CA3 is 15, I mean in total is 50.
50. This is 1, 5, 1, 5, 15, 15, 20. Okay. So let's start with lectures. Before we start, if you have questions, you can ask me. And to introduce myself, I just give my contact details you can get from the web also. So I'm Dr. Mohan. This is my email ID. This is my office phone number. So you can drop an email to me anytime if you have any questions, doubts, etc. Of course, at the end of the class also you can ask. During the class also you can ask. But if you need long discussion, etc., then you need to set up an appointment. Write to me, then you can meet up. Is that fine? Any questions you have before we formally start with lectures? Yes?
The test, is it open book?
The test? No, the test is not open book. And open book means it may be very tough. You should be happy that it's a closed book. And for my part, okay, this is MCQ based. MCQ based. Some may be true or false. Some maybe you may be asked to choose the correct answer from 4 choices or something. Okay, you are familiar with MCQ. It has some advantages. Okay, sometimes it doesn't work good for you also. Sometimes you guess or you think it's right answer. You have a doubt, but maybe the answer is correct. Okay? Sometimes you work hard. Even some simple calculations may be there. Work hard. You got some numbers. You got some answer. The answer is one of the choice. So you think it's a correct answer, you may end up with the wrong answer. Something else could be a correct answer. Okay? So overall, it's not that easy. Simulate is not very tough. Okay? The difficulty level is moderate level. Okay? Sometimes you get marks without knowing it. Sometimes you lose, even though you think through, spend 5 minutes time to get the answer, you get wrong answer. Okay? But doesn't matter. Overall, you should reflect your performance. Okay. Is that okay? For final exams, we allow one A4 sheet, so that any complex equations, formula, anything is that you can note on, not for the continuous assessment. And I don't know exactly about other tests. Sometimes he conducts completely MCQ. Sometimes he conducts a mix of some MCQ questions, some maybe calculations based descriptive questions. Is that okay? Yes.
Maybe around how many questions and is it 1 hour? How long is the test?
I usually design it for 45 minutes. Let's say you have 15 questions. If you know the answers, maybe within 20 minutes you can finish. If you don't know the answer, we cannot do anything, right? There's no point in spending time. It's not the descriptive one, okay. Maybe some simple calculation based questions, some questions will be calculation based, some maybe true or false. Okay, those things you need to work out, use formula to find out, spend some time. But all questions carry equal mass. Whether you answer in 1 second or maybe 5 minutes, still it's the same mass. Okay. Sometimes I used to differentiate, okay, the questions which needs more time I used to give more mass, but some students always feel bad, okay, they spend a lot of time to work out because you get either 0 mark or full marks. There's no partial credit. It's MCQ type. Okay? I do not know how you arrived at that answer. Even if you scribble here and there, so that will not be considered. For final exam, yes, we give partial marks, even though the answer is wrong. Okay, you have attempted, you do some steps, etc. So that means all questions will carry equal marks. Okay? Some questions spend more time, some questions you guess, but still same marks. That means you benefit from some questions, you lose from some questions. Overall should be fine. So I give equal marks. So 50 questions, 15 marks.
For the Linux, which flavor should we install?
Which?
Flavor is Fedora, okay?
I think should be okay.
Or
It doesn't matter because circuit programming should be same for different versions.
Okay. No problem.
Hmm? We start late in October, maybe beginning of October or second week of October, because you need to learn basics, and you need to know. We don't give any separate lecture on circuit programming or anything, but I provide material, a quick reference material to understand, and it's up to you. Okay, I give some simple example programs, you try yourself. Okay? It's more like an independent study. We are not teaching you line by line, okay, this is what it means, this is what it means. No. Okay, it's more like an independent project, you know. You need to learn yourself. So for me, any programming things you don't need actually lecturers help. You go to web, everything, any doubt you have, it will give you a lot of interesting answers. Okay? Is that fine? But still, if you have to struggle with something, some help you can take from the graduate assistants. But not to the extent of solving the problem and all. Is that okay? Some guidance.
May I know, for your part, usually what time the class will be at?
What time the class will
Yeah.
end, is it? Most of the time it will end around 8:45, 8:50. 8:45, 8:50. Because, of course, your class is until 9 or 9:50. I don't know exactly. Sometimes students ask questions at the end. Okay. They want to meet me personally, ask some questions. So I reserve some time. Sometimes they ask, sometimes they don't ask. If there are no questions, so we disperse at 8:45, 8:50. Maybe towards the test or exam, maybe generally students tend to stay here and ask more questions. See. Yeah. Partly because everybody gets tired, I get tired, you also get tired towards the end. So we start around 6:05. Okay, sometimes I may be late by 5 minutes. Okay, by 6:05, let's say we start. You will have 15 minutes break. Then you will have a second session after the break. I don't need to explain much on why we need networks, what's a network and all. Okay? Because now network has become, internet or network has become a part of our life. Okay? But to define formally, okay, a network, when you say network, okay, is a set of systems. It should have at least two. Otherwise there's no point calling it as a network. Okay? So it's a set of systems interconnected by communication links primarily used for information transfer. There could be many definitions. This is one definition. Okay, I use some generic term like systems, information transfer, etc. Because when we say system, okay, it has its own meaning. Okay, there are many things which can be system. Okay, but these systems are connected by communication links. Those links which are used for communicating data from one end to the other. So when you say system, there are many such devices which we call it system here. Sometimes we call it as end system. switches, routers, hubs, etc. So when you say end system, that's the end user. So we are the end system. Okay, let's say I want to use internet. Okay, I want to browse a website. Okay, so how I do it? Either I use a computer, or I use a laptop, tablet, phone. Okay. Sometimes I go to TV, and through TV I try to access some pages, YouTube and other things. Is that fine? So these are all the end systems. When you say end system, we are the end users. That is, end means that's the starting point, okay, or the end point. That's the end system. Okay. So sometimes we call them as host. Host means it is hosting the application. Okay. So when you are trying to browse a web, that means web browsing application is here. That's apps. Maybe later maybe phones and other technologies we used to call this as apps. Applications means apps. Okay. Where apps are running, they are running on the end devices. So these devices systems, okay, could be an end system, or it could be switch, router, hub. Okay, because our system is connected to, maybe you take home, we have a small network. Nowadays we have a network, okay, at home. Okay. So that means you want to access the network, you have Wi-Fi router, so you are connected to the router. Wi-Fi router is somehow connected to the internet outside. Okay, we will see very basic approach how it's done, etc. Okay. So that means there are other components of the network that are called switches, routers, hubs. So later we discuss more in detail how they differ, etc. What are the functionalities? Okay. They all constitutes the whole network. Then when we say end system, as I said earlier, maybe until few years ago, when we say end system, it mostly refers to computers or servers which are also running on computers. Okay? That's why we call this course as computer communication networks. But it's outdated now. Okay? It's not that only computers are communicating, but now many things are communicating. Okay? Even things are communicating. That's why we call it as Internet of Things. So, for example, TV, computer, phone, what are other things communicating? What are the internet devices? Even cameras. So they also have now Wi-Fi and other capabilities. You can connect to the internet. Okay. Increasingly, even the appliances. They are good. Okay. Even the appliances, home appliances, TVs. So there are many things which are directly connected. Game consoles. Right? So they are all internet devices. They are all end devices. They are the end point. Either the data starts from here or end from there. Is that fine? Similarly, servers. So you try to download some web page from somewhere, or try to play games, download some games. Okay, it comes from other system, some other end system. So that end system is usually a server. Could be game server, or video server, okay, or web server, mail server, anything. Okay? So server is also an end system. The links which are used to connect various system elements, various network elements, can be wired links or wireless links. Okay? As an end user, okay, I can either use some Ethernet cable and other things to connect to a network, or wirelessly I can connect. Okay? We have at home 802.11 wireless Wi-Fi. Wi-Fi is one way of connecting. Maybe on the road, maybe you use 3G, 4G to connect to the internet. So there are two ways of connecting, wired or wireless, and different forms of information. I don't need to tell, okay, what kind of information we transfer. It's not just text, but nowadays we transfer more videos, audio, okay, everything, voice, okay, animation, pictures, all are transferred through the network. These are some of the applications, starting from simple web browsing, mails, games, social media, online transactions. So there are numerous applications which are carried out on the network. So now let's see the building blocks of different kinds of networks here. So it's just an example. In fact, the internet today is a very, very complex network. Okay, they are not just one network. Actually, there are many, many hundreds or thousands of networks. Okay, so they are all connected in a very complex way. Though many times we put as a whole picture as a simple networks individually. Okay, but it's not that simple. But anyway, it gives you an idea of, okay, what kind of networks are there and how they are connected, etc. See, for example, look at this. This is a cellular mobile network. The so-called 3G, 4G, LTE, and other things. Okay, now people are talking about 5G. Okay. That means this is a wireless network. Basically, a wireless network. There's a cellular tower. There's a base station. Okay, to which we are communicating wirelessly through computers, our phones, tablets, etc. So we send and receive data from here, which in turn is connected to the ISP. ISP is Internet Service Provider. So there are many service providers in every country. Here you can see Singtel, okay, StarHub, there are players, M1, and new players are coming, like My Republic and other things. Is that fine? So this is one network, mobile cellular networks. What are the end devices? These are the end devices. They are also called hosts because they are hosting. They are also called host because they are the ones hosting the applications. Apps are running here. Applications are running here. Then we have home network. That's until few years ago, even I used to have only one computer at home. Okay, we used to have what's called dial-up modem, dial-up service to connect to the internet. How many of you know dial-up? Have you ever used dial-up? Dial-up? No. The same Singtel's, let's say, telephone cable. We can connect it to computers. There's a telephone socket kind of thing here. And the speed, they say it's 56 kbps. kbps, not Mbps, okay, kbps. So most of the time we get 1 kbps or 2 kbps. So maybe we can browse some newspapers, read some newspapers here and there. And it's charged also. Like this is something like if you use for 30 minutes, something like you are talking to somebody for 30 minutes. So 30 minutes of call charge is made. Is that fine? So you'll end up with paying a lot more compared to today's broadband networks where you pay $30, $40. You have unlimited bandwidth, very fantastic bandwidth, download movies, games, etc. No, it was not like this until few years ago. Okay, so that's one way of connecting from home to the internet. We used to have simple dial-up to connect it, but now it's different. Now you go home, we have a big network. Yeah, big network. There are many devices. Okay, I have a phone. My wife, my children, they all have smartphones. So all the time, almost it's connected to the internet. There's a laptop, some tablets are there, some computers are there. So TVs are there. This one smart TV is there. Okay, all are connected to the game console is there. Some Xbox or game console. It's also connected to the internet. We want to download some games here and there. Okay, so all form a network. It's a home network. So that should be connected to the internet outside. Okay. How they are connected? Maybe later we see maybe in a bit more details. Okay, so you see some, so you can see some wireless laptop, maybe phone, etc. I don't show all the devices here. Then you have something called wireless access point, and there is a router. In fact, I mean commercially these two come together as wireless router. Okay, there's a wireless router. Okay, so it's not separately wireless access point and router, but maybe in campus here you can see wireless router access points will be there. Maybe later other next level of routers will be there. But at home, usually they do many functions together. Okay, these two. So we are connected to the wireless router, which in turn is connected to the internet outside. Is that fine? The service provider's network outside. So this is a home network. And you can also have, if you look at the wireless router, there may be some Ethernet ports you can directly connect. I mean, you can have a wired network also. That means usually wired networks are faster compared to the wireless network. So if you want, maybe let's say you have a TV most of the time, you want, I mean, high bandwidth, you can directly connect through a wire instead of wireless. Or if you have game console, many times you download 10 GB, 20 GB games. Let's say you have Xbox One TV, 2 TV, okay? So several times you want to download, so better to connect directly to the router through wire instead of wireless. Both options are there, okay? So some could be connected directly, some with wireless through wires, some wireless, some have wireless connectivity. And this device, we call this as basically base station, okay? And such base stations could be for Wi-Fi or could be for the cellular. For cellular base stations is a tower, cellular tower. Okay? Communication links could be based on fibers, optical fibers, or coppers, like the cables which you have, which you normally use to connect your computers or other things. Okay. Or it could be the cables like the TV cables, coaxial cables. And wireless, they use radio signals as well as the microwave for satellite communication. Okay. Satellite is also used one way of communication between countries or where you cannot establish, you cannot give, let's say, broadband connections directly like Singapore, so you can communicate through satellites. And you can also see some devices something like this. So this we call them as switches, okay, or it could be routers. Later we differentiate what's a switch and what's a router, but basically it's used to take the data from, let's say, what we generate data from here, and they are used to route the data. Okay. Let's say data arrives at this switch, it has to decide, it will take a decision whether it has to be sent here or here, based on the destination address. Okay, so it does some function, switching or forwarding function. So it takes a piece of data and decides whether it should go this direction or this direction. That is a switch or router. Is that fine? So let's get some idea of how data is transferred between two end hosts. Just a simplified example. So most of the time what we do is we download. Okay, we are more interested in downloading data. Okay, whether you access web page or you watch YouTube, okay, use some video or you play games, mostly is the downloading from the other side. Okay? So that means there is one host, let's say a computer host here as an example, but as I said, this host can be any phone or anything else. Then we have a server host at a remote place, which is connected to a different network. We do not know where it is connected. Okay, but many times nowadays the servers are part of data centers or cloud. So let's not worry about this. Servers are also end host because they are the end, they are the source or the destination of the data. And this host, what it does is it generates data. Let's say you want to send from one end to the other end. Maybe the sender can be this, the receiver can be the computer. Okay, so you want to send a large chunk of file. Let's say one web page, one game, one video file. So everything is one data, one piece of data. Okay, and usually that piece of data is not sent is a whole in one single packet or something. So there are many reasons. One reason is that if you send this as a one, let's say you are trying to download an image. Okay. Let's say 1 MB image, 1 megabyte of image. Let's say you are trying to download a video file. Okay. So the size could be 1 GB. Okay. So at least some 720 pixel video. Okay, that's 1 GB of video file you want to download. Okay. So this video file will not be sent as one single packet. Usually it will be split into a number of small packets. There are many reasons why we split. Okay. See, for example, if you send one single packet from a remote place here, it goes through many communication channels. Okay. So there's a possibility of errors. Meaning that somewhere 1 may become 0, 0 may become 1. Signals may be attenuated or corrupted, okay, or there could be false. Is that fine? So even if one bit is corrupted, the entire 1 GB of data will be waste. You have to throw it because it's difficult or almost impossible to find which bit has gone wrong. Is that okay? Maybe for video and all, some bits can be tolerated, okay, but other files like emails and other things, transactions, no, you cannot afford to accept even 1 bit loss. So that means we have to resend the entire data again. Is that fine? So for some reasons we split this into small data. So this we call it as packet. And before that, there is a logical connection created between this and this, between the two endposts. That's the first step. That is an end-to-end logical connections or channel is created. That connection we call it as TCP connections, so that we will study later. Okay, we'll look at it later. So it's a logical connection. Physically, there's no such pipe or connection. Okay. So logically, there's a connection. So they come to an understanding. Okay, I'm going to send data. Are you ready? Okay, I'm ready. Okay, let's exchange data. That's all. The data is sent through the channel. That means the data will flow through the channel which passes through a number of networks. And at the end, usually we have an access network. It could be wired or wireless. We will discuss it later. Okay. Then it goes through some core network. Core network, usually they are wired networks. Then at the end again, there could be an access network. Finally, you get data from the remote host. So when the packet goes through different networks, it actually goes through different routers or switches. So then there's an issue of routing. So how they are routed, what's the best way of routing. Okay. So if you look at the book, they always give an analogy of the road transport. Okay. So you want to, let's say, go to some place from your home or some place, how you go. Okay, you start from the parking lot, car parking lot, okay? So let's say you are at home. First, you need to reach the main road from your home. Is that okay? For some home, maybe easier, direct entry. Maybe let's say you have an independent landed house, you just come out, and then you enter into the road. Okay? But for some apartments or condos, you have a car park. There itself, okay, you need to struggle, go here and there, then reach the road. Then you go to a mall, car parks, there are some ways, okay, to reach the road. That we call it as access. This is the access network, okay. That means how you reach the first entry point of the road, main road, okay. But once you reach the road, then you travel through this, but you encounter some junctions. There are some junctions, okay. At the junction, you need to decide. Okay, whether you need to go straight or right turn, left turn. Okay, there are multiple ways. Okay, so that is something like a switch. Once the packet reaches here, it has to decide whether it has to go through this or go through this. So we know based on our history and other things. Okay, we can go by this way or this way. Okay, is that okay? Somehow we travel and reach the other place. This is traveling, but if you think. Same example, like we are trying to transport, let's say a few boxes. A truck starts from one place and reaches other place. Okay? And we put small boxes into a bigger box. Okay? Then you transport them from the truck. It goes through many roads and reaches them. Where okay, you do some other operation and everything is done. Is that clear? There are two kinds of switches. We call it as link layer switch and network layer switch. The good example is Ethernet switch. Usually it's called link layer switch. That means mainly they operate at the level of the link. You have a communication link. There's a switch here, switch here. There are some functionalities which are carried out on the link. So those functionalities are carried by the switch. There are some switches, we call them as network layer switch or layer 3 switch. Anyway, we will discuss later, okay, in detail, okay, why there are differences and what are the other differences, okay, why we call it this as router, the other one is switch. So here example is Ethernet switch, here the example is IP router. Both are switches. Technically they are switches, but commercial term is Ethernet, we call it a switch, router, IP router, we call it as router. Okay, there are different functionalities, okay. But generic name is a switch. That means you receive a packet, you switch to this output link or this output link. So we call it as switching. Once the packets are received at the receiver, they will be assembled back into original data. Let's say you divide the file into 10 packets at the source host. All these 10 packets will go through the network, one or more networks. At the end, we receive all of them. Okay. It's not that the whole function is simple. Why? because when you send the packets through the networks, as I said, errors may be introduced. Okay, some bits may be corrupted. What we should do? Okay, there will be some faults. Suddenly when it goes through a link or port failed, a switch failed, router failed. Okay, so some link may fail, may become faulty, switch may become faulty. So what should we do? There is other problem also. Though we say it's a logical connection from this end to this end, okay, physically, actually, in practice, these 10 packets, okay, need not go through the same route. Okay. Maybe one may go through this, maybe another packet may go through this, but logically there's a connection. Physically, packets may take different routes. This is something like 10 people. Okay, we all start, we want to go to another place, everybody has a car. Okay, so we just say that, okay, that all of us reach the other place. So we start one by one, 1, 2, 3. But if you take different routes, there's no guarantee that, okay, car 1 reaches first before car 2. Is that fine? You take different route, and or you go to that route, oh, suddenly you find that, oh, there is some work going on, or let's say bridge is closed, now you have to take alternate route. Okay? So finally, the cars may end up in a different order. Similarly, here packets may end up in different order. So we need to do something extra to put them back all in the order. So that is done at the end of study. So when you say logical connection, there's a TCP protocol which does all of it. They take care of putting things together in order. Now everything is done. Next, how fast we can transmit through a link. So we have seen there are two kinds of link, right? Wired link and wireless link. A link is a communication channel. Sometimes we call it as a channel, sometimes we call it as a link. Is that fine? So you have a computer, connect through a Ethernet cable to a switch or router, there's a link. Two routers connected by a cable, could be a fiber cable link or the coaxial link, it's a link. Wireless link, you communicate through Wi-Fi, communicate to an access point or some router, okay, by wireless means, or you communicate through the cellular towers, base stations, okay, by 3G, 4G, that's a wireless communication, okay. Now, how fast we can communicate? That depends on the link capacity, okay. It's not that we can transmit at any speed. So what do you mean by the transmission speed? How many bits you can transmit in 1 second? Let's say we want to transmit 1 megabyte of data. How long it takes? We download, let's say 1 megabyte of data, how long it takes? Let's say you want to send 1 megabyte, you take a nice picture and you are trying to send from your phone or computer. Just 1 MB, okay, you're trying to transmit. How much time it takes? It's not immediate, okay? If the picture quality is better, size is bigger, it takes more time. So it depends on the speed of the link. So the number of bits which you can transmit in 1 second, that defines the speed, how fast you can go. It is associated with every link. Link is characterized by 3. 1, bandwidth, data rate, then capacity. Link capacity or channel capacity, link bandwidth, link rate, transmission rate, data rate, bit rate. So these are all the 3 parameters which we use to characterize a link. What is bandwidth? When you say communication channel or link, when you say bits are transmitted, 1 by 1, okay? Logically we say ones and zeros are transmitted, but actually the signals are transmitted, okay? We need signal to transmit. Okay, associated with the communication channel, that's a signal, that's a bandwidth. When you say bandwidth, it's called width of the frequency band. Okay, so let's say you take a telephone line, okay, we need 4K bandwidth, usually 0 to 4 kilohertz bandwidth is used for us to transmit our voice frequencies, because most of our frequencies are in 0 to 4,000. Actually 300 to 3,300 hertz. Okay. Similarly, you take TV channel, the cable TV channel. So the frequency, depending on the standards, could be 6 megahertz or 8 megahertz for one channel. Okay. So if you want to use telephone links, the telephone channel as a link to communicate, then we can use 6 megahertz or 8 megahertz of that channel to transmit. Is that fine? So it is the width of the frequency band, okay, which defines the bandwidth of the channel on the link. It's measured in hertz. The unit is in hertz. Okay. And the related term is data rate. That means if you have higher bandwidth, usually we should be able to send it at a higher rate. Okay. Then what is the data rate? It's also called transmission rate. It's defined as the rate in bits per second. How many bits can be transmitted in 1 second? So even though you send a full 1 MB of data, when it's transmitted bit by bit. It's not byte by byte. Okay? So transmit first bit, second bit, third bit, fourth bit. So that's a transmitter to transmit. That's a receiver. We call it as transceiver. Okay? So how many bits you can put on the link? How fast you can do? That's the transmission rate. Okay? That is measured in bits per second. Mbps, Gbps. So when you have broadband connection at home, okay, the provider will say 100 Mbps. You can have 100 Mbps broadband service, 1 Gbps. Okay? Basically, they refer to bits per second data rate. Then comes channel capacity or link capacity. It's basically the maximum rate at which data can be transmitted, subject to some constraints like signal to noise ratio. You take any channel, wireless channel or wired link, okay, it has a maximum capacity. You cannot transmit more than a certain rate. If you transmit that, then you lose the bits. There will be a lot of attenuation, so your signal will be lost. Is that okay? That means you cannot use the telephone cable to transmit, let's say at the rate of 1 Gbps or 10 Gbps. We need something like a fiber to do this. You cannot use wireless channel to transmit 1 Gbps rate, no. Okay, of course 4G now they say you can transmit at the rate of 150 Mbps or 300 Mbps, but most of the time you cannot get it. But still you are not able to go beyond that. You cannot use your phone to transmit 1 Gbps rate. That means 1 second you will be transmitting 1 gigabits. You also may not want, because for 1 GB how much you are paying, okay? You will use up in few seconds. Is that fine? You can easily make calculations. So how much data you transmitted and received. Is that clear? So but these three terms are related, they are not the same. But many places in our course, we see that we use these three terms interchangeably. Sometimes I say, okay, there's a link bandwidth, 10 Mbps bandwidth. What actually I refer is a data rate, it's not bandwidth. Okay? Is that okay? It's allowed. Even if you read the book, sometimes they say the bandwidth is 100 Mbps. Sometimes they say link rate is 100 Mbps. Or link capacity is 100 Mbps. Doesn't matter. You look at the unit that will differentiate. Okay? If I say link bandwidth is 8 megahertz, then actually I refer to the bandwidth. Okay? But if I say link data rate is 10 Mbps, data rate. If I say link bandwidth is 10 Mbps, again I refer to data rate. It's not bandwidth. Is that okay? So don't need to get confused. So now let's look at the different kinds of links. There are two kinds of links. One we call this shared link or broadcast link. The other one is point-to-point link. When you say broadcast, it's also called shared link or multiple access link. That means one link shared by many. One link shared by many. Usually it is in the access network. So a good example is wireless. Okay, same bandwidth many people share. Okay? In the case of wired network, you can imagine, starting from 70s. So the idea was, of course later it was replaced by hub and other things. The idea is you can have a cable in the room or the lab on the wall. Okay, it will have some sockets, Ethernet sockets here and there. You can go and plug in your computer to the Ethernet network. Okay. So let's say there's a Ethernet cable running around this. So this is something like this is a cable. These are your computers. You connect to the Ethernet network socket through a link. Okay. Earlier you used to have a lot of sockets here and there in the campus. Now everybody is using wireless. Okay. I don't know whether still extra sockets on the wall here and there. Okay, is that okay? So that means all these computers or the hosts, they use or share the same cable. Usually it's localized, maybe within a room, within a small office, okay, something like this. So if this is basically Ethernet cable, this forms actually a network actually. Okay? It's network now. All are connected. Okay? So if this cable speed is, let's say, 100 Mbps, and let's say the network adapter, which is inside the host, that's also usually, it is also 10 or 100 Mbps. Okay? If you have a computer, okay, usually it has a network adapter. It comes with certain speed. The Ethernet adapter, usually 100 Mbps adapter is there. That means you can transmit maximum at the speed of 100 million bits per second. Okay? That means everybody can transmit. If this host wants to transmit, it can transmit at the rate of 100 million bits per second. This one also can transmit at the rate of 100 million bits per second. If it is a broadcast link, meaning is that one transmits, everybody receives. One transmits, everybody can see. That is broadcast. One sender, all receivers. Then, of course, we don't want everybody to receive and process into the computer, right? Adapter receives it. But based on the destination address, only one accept, others throw it. Is that fine? That means if this wants to send something to this, it specifies the address, it puts data packet onto the link, which can be seen by everybody. Everybody can see the packet. But only this fellow who knows that this address is meant for this will copy it for the processing into the computer. Others will just throw it at that level. Only network adapter can see, but they don't copy it for other processing. Okay. What is the advantage? The advantage is it's very simple. Same simple cable is shared by many. Okay. When you say it's a shared link, shared access or multiple access, that means many people are using the same channel. They access the same channel. That means at any time only one can transmit. If more than one try to transmit, there's a possibility of collision. Their bits may collide. Okay, let's say this fellow is transmitting something, he is also transmitting something, so the bits or the signals will collide each other. That means one may become 0, 0 may become 1, so it's useless. This becomes useless. So we need some mechanism, okay, to detect, okay, whether there's a collision, how to deal with this, etc. Okay, that's a different protocol which we discuss later. Okay, but there's a possibility of collision when many people use the same link. The advantage is simple, and the cost-wise is very low. It's a low-cost, simple solution. Okay, and when you say multiplexers link, that means if one host is transmitting, let's say, at the rate of x1. You take 1 second time. Let's say host 1 transmitted x1 bits. Host 2 transmitted x2 bits, number of bits, x3 bits. If you sum up everything, that should be less than or equal to 100 million. You just take any 1 second time. Everybody has transmitted certain number of bits. If you sum up, it cannot exceed 100 million bits. Individually, they can send 100 million bits per second. But since many people are there, this may be spending for some time few milliseconds. This may be sending for few milliseconds. Okay, but as a whole, it cannot exceed 100 milliseconds. That's a characteristic of broadcasting or multiple access link or shared link. Is that clear? This could be wired or wireless link. Mostly, it's used in the local area. We call it as local area network. What do you mean by local area? It could be within a home, within a company, within a room, within a small office. So geographically, it's local because they are close by. There's another class which we call it as point-to-point link. Point-to-point link is typically used in switched network. Some examples are campus network, then internet service providers network. When you say campus network, company network, enterprise network, institution network, that means there's already a network in place. Let's say university you take. Okay, there are small labs, offices, they are connected. Outside also they have routers, switches to connect everybody, everything. Similarly, you take any organization, university, bank, company, anything, so they all have their own network, okay? So, but when you say switched network, that means it's a network of switches. These are all switches or routers. They are all connected by these links. These links are called point-to-point links because the link connects only two. Let's say you take this link, it connects 4 and 5. So if 4 sends a packet, 5 receives. If it's a shared link or broadcast link, if 4 sends, everybody should receive. Am I right? No. If 4 transmits, only 5 receives. If 4 wants to transmit something to 3, then 4 has to transmit to 5, then 5 has to switch. In the sense that it has to see from here, it will put either on this link or in this link. Depending on some criteria, then it will reach here or it will reach here this way. Is that fine? Similarly, 6, 5 can communicate to 4. It's a point-to-point link. It's not a shared link because it is not shared by all. It is used only by the end nodes. That is 4 and 5. The advantage is that if this link capacity is 100 Mbps, it's entirely available to this. It's not shared by others. Is that fine? But here there's a problem of routing. In the case of broadcast link, there's no routing. If this wants to send something to this or this, you just broadcast. Then whoever is interested, they take it. That's all. This is something like TV broadcasting. Okay, everything is sent to everybody. So if you are interested, you watch this. Otherwise, you change to something else. That's all. Local area here, maybe later we look at. Here, local area means that geographically it's localized. It's quite nearby, few meters, something like this, inside a room, in one floor or something. Wide area on the other hand, which we will see later, it could be on the city level or between two countries. Okay? That means one router is here. If one router is here, the other router could be after 10 kilometers or 100, or maybe in big countries, and the link can be 1,000 kilometers long. Or there can be links connecting two neighbor countries. Nowadays, countries are connected under the sea also. Okay, fiber links are there, even between Singapore, India, and other countries. There are fiber links under the sea. So you can imagine thousands of kilometers. Okay, it's long links are there. Is that okay? So they are all basically switched network point-to-point links. They are not broadcast links. Broadcast links is wireless. Good example is usually our data. Okay, we have network at home. Many users are using, so actually they are sharing the same wireless media. Okay, so more and more users start using it, then your bandwidth, your bandwidth share will be smaller. Any doubt so far? So again, let's revisit the big picture, the whole network structure. So there are different ways to look at it, but the overall structure is something similar to this. We have home networks, mobile networks, the enterprise or institution, company, campus. There are different names. Okay, there's another network here, and they all have different structures. For example, if you take institutional networks, you have some wireless part. That means you can connect wirelessly. You can see the wireless access points here and there on the corridors. So you can connect wirelessly to the internet, or maybe you go to the lab, there's a wired network, okay? You go to the lab, there's a wired network. There also you can connect. There are many routers and other things, so they are all connected. At the end, from the institution gateway, there is a gateway. There's a link which connects to the external service provider. So you have a service provider network, and maybe in Singapore there's a one level of service provider network. Okay, then they connect to the global ones outside to the other countries. Maybe for big countries there will be different levels of service providers, small scale, large scale kind of thing. So maybe we call it as regional service providers, which provides maybe a city kind of thing. Then maybe the next level there will be another level of service providers, then another level of service providers, then finally you can have multiple levels of service providers. And these service providers networks are basically core networks, we call them core networks, okay? And they are basically switched networks. They usually have switches and routers. Okay? They don't have wireless connectivity within them, or they don't have simple shared Ethernet kind of thing. It's a switched network. Anything, any local area network, okay, it comes within the campus or home. So you can see there's a wireless network here. Sorry, local area network here. Okay. Is that fine? But these are all wide area networks kind of things. And this, we need what's called access networks to access internet. See, let's say, for example, you take the service provider. So the first router to which we connect from our home or from country, from our company, that's called edge router. There's the edge. This is the edge. Edge means that's at the bottom. Is that okay? Then from our home or outside cellular network or from home or from any company, we try to connect to them. How we connect to the internet? There are different ways. You take home, okay, we need a broadband service, right? Either from startup or Singtel or fiber. Fiber is provided by everybody, fiber broadband. So, but if you are outside on the road, you need 3G or 4G. You are in the campus, you need a different kind of infrastructure to connect to the internet. Is that fine? So accordingly, we define network edge and network core. This is the core. These are the edges. That's the first. So these are the edges. These are the edges here. They are the borders. And these networks are called access networks. Later we see some more details about why we call it as access networks. They are used to access the internet. That's how you can do. Okay. That is the last mail networks. That means that is the end. Network core. Basically, this is network core, which are connected by routers or switches. So let's look at different kinds of access networks. How do we connect end systems to the edge router? For that, we need access network. Broadly, as I said earlier, there are broadly three kinds of access networks. Either we are at home, on the road, at home, okay, or in the campus. Okay. Within the house or residential network, so you can have something like this. As I explained before, okay, these are the devices which we have, internet devices. We connect to the wireless router, either wirelessly or through wire. There's a router here. Okay. Actually, this router and the wireless access point usually they come together. Commercially, they are available together. We have only one router there at home, right? It also connects wirelessly, and we also have the ports, Ethernet ports to connect through Ethernet cables and other things. Okay, this is the kind of structure. But here, this is a different structure. You need to have 3G, 4G connection to connect to the cellular tower. It's a cellular mobile network. Campus, you can connect through wireless or wired, and you can also have multiple routers here. But the basic types of access networks, because sometimes students get confused. You see, here also you have access, here also you have some wireless, okay, and the kind of connectivity here between this to this, or let's say between this to this, and the institution, they're all different, okay? So let me try to define basic types of access networks to avoid all the confusions. There are 5 basic types. 1, telephone line based or network based access network. So you can subscribe to Singtel, okay? So they give you what is called, I'm not talking about the fiber broadband, but ADSL. Okay, you have ADSL. So you take any country, the telephone network service providers, they provide broadband service. Okay. Is that fine? It's a residential broadband service. There is one way of connecting to the internet. This is one type, telephone network based. The other one is cable TV network based. That means the telephone network infrastructure is used to provide the internet service. That's why it is with the control of the service providers are usually synced, that means telephone service provider. Similarly, cable TV infrastructure can be used to provide network services. Okay, so in Singapore we have startup, so they also provide network service. It's a cable modem based network service. Okay, there's another thing. That means how you can connect to the internet from your home. So these two normally we use at home. Doesn't mean that you cannot use as maybe small companies you can still use it. Okay. Then we have what's called fiber network based access. Nowadays increasingly Singapore it's becoming very popular, right? Because we are not satisfied with them. I think maximum we used to get 50 sometimes 100 Mbps with the cable modem and other things. How many of you have fiber broadband at home? Only few. But at least you must be knowing, right? Or you may want to use some fiber broadband. The prices are coming down. Okay. Earlier, even few years ago, 20 Mbps simple cable modem service, we had to pay around $60 or something per month. Now, if you pay now $49, you get 1 Gbps connection. Sometimes dual connection also. Okay. Is that okay? So the price is going down, but fiber has an advantage. The capacity is huge. And that's why it's able to provide more bandwidth, higher bandwidth to individual home. So there's another way, that is fiber network. This is a third kind of access network. But still we need some network infrastructure. It's not just a simple cable. Okay? Is that okay? It has to follow some network, some protocols, etc. So later we'll see an example, okay, what is this fiber-based access network. Then comes local area wired access network. That's also an access network. Local area wired access network. So local area is something like this. Okay, so you can have something like this network even at home or the institution. Okay, then you can connect this to your router outside. Next, local area wireless access. There is another way of accessing the network. 802.11 wireless LAN, Wi-Fi. Maybe better you call it Wi-Fi. Wi-Fi everybody knows. Okay, that's also, it's a wireless access network. We also have wide area wireless access. That's basically cellular mobile network, area network. So these are the different ways by which we have access to the internet. Okay, we have access to the first router to which your host is connected. So that they all form the access networks. Any doubt you have? Any doubt?
For the wireless network, right? For the wireless network, if we use the wire to connect to other countries, it's the undersea cable, right? But for wireless, is it the
You want to connect wirelessly or to use satellites? Between countries, no. Still, satellite is used. But we may not have sufficient bandwidth like fiber. Fiber has more bandwidth.
So using the keyboard is more better.
But satellite is also used. Even for telephone connectivity, also satellites are used. Telephone networks also, yes. Still, many countries are connected by satellites. Okay, let's briefly look at the key ideas, the structures behind the access networks. We're not going very deep into physical level details, the signal levels and other things, but as a block box level, okay, how it is done. Some basic principles, that's all. First, let's start with what's called digital subscriber line, DSL. There are many DSLs. Quite popular one which we use here is ADSL. Similarly, we have VDSL, HDSL, okay, high-speed DSL, very high-speed DSL. Okay. there are different kinds of DSLs, but let's not worry about this. So what does it mean by, what do you mean by digital subscriber line? So the key idea is use the telephone infrastructure. Okay? In other words, use the same telephone cable which connects your home to the service provider, okay, to transmit data. Already your house is wired, right? There's a telephone, usually you can have the telephone socket which is connected somewhere outside to the telephone network. Okay? Can we make use of the same cable for the data services, internet services? That's the question. Okay? We use it for voice, but when we use it for voice, the signal which we use is up to 4 kilohertz. That's sufficient. We can band limit it to 4 kilohertz. We don't need more than 4,000 hertz because our voice frequencies are mostly in the range from 300 hertz to 3,300 hertz. Okay. Other signal components are very insignificant. Okay. That means beyond 4K you don't need, and the voice will be clear. Is that fine? So earlier, as I said, now we used to have dial-up modem. We use the same telephone cable, but we have to use this frequency, same frequency, 0 to 4 kilohertz. So that means the data rate was limited actually to 56 kbps modem. As I said, we used to have but 1 kbps only. Just to read one newspaper, one page, it takes a lot of time. Email access and all very, very slow. Now we think very slow. Maybe at that time we were happy about it, okay, but now we cannot use anymore any dial-up or anything. Just throw it, okay. But then same cable is used for data transmission, internet data transmission at a higher rate. Let's say 10 Mbps, 20 Mbps, quite common, okay. So how do we do this? So this is the DSL structure. So what we have at home is DSL modem. This is a telephone socket, okay. So it connected to a modem. Of course, the telephone voice. Still, you can connect to telephone as well, okay. So from this modem, okay, this is connected to the host computer or phones, etc. You can connect it to your wireless router here, so that you can support multiple devices, or you can directly connect to Ethernet cable to this modem. So these signals, both voice signal and also the data signal, both go through the same link, but they use different frequencies. They use different frequencies. For voice, 0 to 4 kilohertz. Then similarly for upstream and downstream. Upstream means from the user or home to the service provider. That's upstream. Downstream means service provider to the home. Okay. So there are 3 different frequency bands which are used. Same link, but different frequencies are used through the dedicated link. There's a link from your home to the service provider. Okay. Service provider equipments are located in what is called central office. This is the business term, CO, central office. Okay. So there's a central office here. There we have DSL access multiplexer, DSL AM. So all DSLs are connected to DSL AM. That means there's a home from here, there's another home from here, everybody has a connection. It goes to the DSL AM. So what it does, now it has to separate the voice and data. Okay. So earlier it was not that. Now voice signals will be separated here, is a multiplexer, and the voice frequencies will be sent to the telephone network by the multiplexer, and the data frequencies will be sent to the service provider network. Because telephone network has its own equipment. They have their own multiplexers, DS1, there are different levels of multiplexers, circuits, basically a circuit switch network, and this could be packet switched internet service provider network. But what is important is that we are able to access through the same telephone cable which is used for voice communication from our home to the service provider network. DSL goes to internet and voice goes to the telephone network, then upstream and downstream bandwidth could be different. For example, upstream bandwidth is 2.5 Mbps. Usually upstream and downstream bandwidth are different. Okay? Even DSL, cable modem, everything. So why there's a difference? They want to use, okay, why there's a difference? Because based on the need also. Most of the time we download rather than upload, okay? We download more data than uploading. Agreed or not? Even though increasingly we also tend to upload more with all these social networks. Click, 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 you take photos, videos, immediately you try to upload, okay? So the upload speed also we need, but still the download speed needs to be higher because we need more, we download more compared to upload. Okay? So accordingly, the services, the upstream rate and downstream rate we should be different. So though it says about 25 Mbps, I mean later I think improved with a different DSL technology. It could go up to 50 Mbps or something. Okay, but then if you want to go beyond that, go for fiber. There's no other way. Any doubt? Maybe we'll have 15 minutes break. So it's on 40, we come back again, maybe for about 1 hour.